All right. Hey there, everybody. This packet that I am going to be working through is in the Google Classroom. So if you look under week 7 and the Wednesday assignment, which you would already be in there to access this video, there should be a PDF version of this document. So as you're working through it, you can either pause the video right now and print a copy off for yourself if you have a printer at home. Otherwise, you can just look at the document on the screen and write out the notes and the homework in your notebook. It's up to you. Either one is fine with me. What we're going to be talking about in this video is focusing specifically on setting up and solving story problems, and then solving the systems. So let's just jump right into it. So number 1, it says the Crazy Carnival amusement park charges a $35 entrance fee plus a charge of $2 per ticket. The Happy Fun Time amusement park charges a $20 entrance fee plus $3 per ride ticket. Now, here's the important part. You have to look for what the question is. What number of tickets is the total cost the same for both parks? Because what the question is asking is going to tell us what our variables are going to be. So what do I have to find out? I have to find the total number of tickets and the total cost so they're the same. So X is going to represent the number of tickets and Y is going to represent the total cost. Now it says write the system and solve. So let's write an equation for the Crazy Carnival park. So the total cost at the Crazy Carnival, so Y, which is my total cost, is equal to 35 plus $2 per ticket. So that means we have 2x. So that's for Crazy Carnival. All right, K for Crazy Carnival. The Happy Fun Time amusement park, HF for Happy Fun, we get the total cost being $20 plus $3 per ticket. And now I have a system and I can find when these two are equal to each other. And this system is set up perfectly for substitution. And again, it's up to you how you want to solve it. But this one is definitely set up best for substitution. So I'm going to take that 35 plus 2x and put it in the place of y, which is going to give me 35 plus 2x equals 20 plus 3x. Now I'm going to subtract 2x from both sides, which gives me 35 equals 20 plus x. I'm going to subtract 20, which means that x equals 15. Now I'm not done. I have to go back and find y, and we're going to go plug that back in. So y equals 35 plus 2 times 15, because x is 15. 35 plus 30, y equals 65. Now, here's the important part, and this is something you're going to have to be able to do on your test, is interpret the answer. Yes, we found that x is 15 and that y is 65, but what does that mean in the context of this scenario? What did they actually ask us to find? What number of tickets is the total cost the same for both parks? Well, remember, x represents the number of tickets and y represents the total cost. So what that means is that if you buy 15 tickets. The cost will be $65 at both parks. So that's now taking our answer and putting it back into the context of the problem. Okay, let's try number 2. Number 2 says there are a total of 18 monkeys and orangutans in a primate habitat. The monkeys each eat 5 bananas a day, and the orangutans eat 8 bananas a day. Each day, the monkeys and orangutans eat a total of 111 bananas. How many monkeys and orangutans are there in the habitat? So, what is the question? The question asks, how many monkeys and how many orangutans are in the habitat? So, I'm going to say X is the number of monkeys, and Y is the number of orangutans. Isn't it weird that we say orangutan, even though there's not a G at the end of orangutan? It sounds weird to say orangutan. I don't know. That's a side note. Okay, so let's reread this. There are a total of 18 monkeys and orangutans. So that means that X plus Y is 18. Because the total of monkeys and orangutans is 18. Monkeys plus orangutans equals 18. I need another equation, and it's going to have to do with the bananas. So we're told that the monkeys eat 5 bananas a day, the orangutans eat 8 bananas a day, and they eat a grand total of 111 bananas in a day. Well, each monkey eats 5 bananas a day, so we're going to have 5 times the number of monkeys, plus 8 bananas times the number of orangutans, and that's going to equal our total of 111 bananas. And that's our system. Now, this system is set up for elimination. Well, I guess you could do elimination or substitution. I'm going to do elimination just for fun. Now, let's say I want to eliminate the x's. To get rid of the x, I could do a 5x and a negative 5x. So I'm going to multiply that first equation by negative 5, which gives me negative 5x, negative 5 times y is negative 5y, negative 5 times 18 is negative 90. Okay, now I'm going to add these two together. The 5x and the negative 5x eliminate. 8y and negative 5y is 3y. 111 plus negative 90 is 21. Now this is a problem I can easily solve for y. We get y equals 7. Now, I know that x plus y is 18, which means x plus 7 is 18. So if I have 7 orangutans, that means I must have 11 monkeys. So again, we have to take our answer and interpret it in the situation. Remember, x represents the number of monkeys, y represents the number of orangutans. So what that means is there are 11 monkeys and 7 orangutans in the exhibit. There are 11 monkeys and 7 orangutans in the exhibit. Okay, So I just did numbers 1 and 2 with you guys. You are going to do number 3. And 4 through 6. And 7 and 8. So you're going to finish up the rest of the story problems. Now, I want you to look at this part where it says special cases practice. So special cases means that we either have no solution or infinitely many solutions. And the rest of this page and the last page of this packet are kind of walking you through some different scenarios when one of those cases occurs. So one of the first things we talked about is that if a system has no solution, that means the graphs of the lines are parallel, right? And this makes sense because if I graph 2 lines and they are parallel, that means they are never going to intersect, which means there's no solution. If a system has infinitely many solutions, the graphs of the lines are the same. So remember, that means that the 2 lines are basically going to overlap each other perfectly, which means they intersect each other at every single point on those lines. So you are going to walk through number 9. And this back page here, all of these problems are talking about these special case scenarios. So you're going to finish this packet up through number 13. So you're going to do some story problem practice, and you're going to do some practice with the special cases. If you have any questions at all today as you are working, please send me an email. I'm more than happy to meet with you one-on-one and go over any questions that you have. Thanks, guys.